Hey y'all, welcome back to Code in Pink. I'm Naya Lucy, and this is another episode of Before the Code.
If you ain't got no money, take your broke ass home.
Okay, I'm gonna keep it real. I don't really know how I feel about my childhood room being the background. Girl, it's gonna have to do because it's lighting his head. This is episode 2. We are going to be talking about the various components that you need to know about in order to have a perfect running program. So we're gonna get started with that, and we're gonna start off talking about statements. Statements are basically just an instruction in a program. Just something saying, this is what I want you to do. And if you recall from last episode 1, we basically talked about how a program is basically just a series of instructions of what we're telling the computer exactly what we want it to do. So a program can literally be thought of as a bunch of statements, really. So a statement could be used to declare a variable. It could be used to initialize a loop or to print out a statement, receive input and what to do with that input. All of these can be considered statements, which leads us into the next most important thing, which is syntax. Syntax. Okay? Syntax is so important because if you don't understand syntax correctly, it can throw off your entire program, and you don't want to waste your time constantly going back and forth, trying to debug, change stuff up. No, we don't got time for that. So we're going to talk about syntax. Just like in the English language, there are certain things that we use when we read and write to make sure that we understand and can communicate properly, such as commas to avoid run-on sentences, or periods at the end of a sentence to basically say that we're done with this statement. We have capital letters to initialize whether or not something is of importance, or a proper noun for the beginning of a sentence. We have certain ways that we do our spacing. We have certain ways that we write our sentences between the placements of our nouns and our verbs to make sure that we're making proper sense. If I said Naya Lucy ate the pizza versus the pizza ate Naya Lucy, or Naya Lucy pizza ate, all of those mean completely different things. One of them doesn't even really make sense, but that's exactly how it works with programming. It's very important that you know the rules because that is the way that the compiler is able to understand what you're saying and relay the message to the computer so that it can carry out the task that you're trying to perform. So I'm only gonna go over a few syntax examples just because I feel like that's really something you have to learn more in depth as you go through programming. So as we go through the programming series, you'll learn more and more. My main focus right now is that you just understand what syntax is. So once you start programming, if you get a syntax error, you'll know that it's like a programming grammar error. That's a lot of grams, but you'll be able to understand, like, okay, maybe I didn't insert a comma. Well, usually it'll tell you. Okay, I'm just trying to make sure you know what the word syntax means, okay? Syntax. Moving on. So for instance, when it comes to naming variables or naming different things when programming, you really can't use spaces. So for instance, let's say we have a variable and the variable is called we're going to call it student ID because technically, those are two different words, kind of. And there are different ways you could write it. You can't really write student space ID is equal to whatever. No, instead, you could do something that we call camel casing. When we camel case, we lowercase the beginning word and then we capitalize the second word and then we put them together. But that way we can have a differentiation between the first word and the second word so it doesn't look like student id. Okay, it doesn't matter. So that's one way. Another way you could do is actually use underscores, which a lot of people use underscores as a way of symbolizing where a space is supposed to be. So student underscore ID is equal to whatever. Something else that's important is making sure you know how to end statements when programming. So we'll be working in Java, and in Java you have to use semicolons. So the same way that you would end a sentence to move on to whatever else you have to say with a period, you're going to use a semicolon in Java. That is very, very important, because if you don't place a semicolon at the end of your statement, it's going to think that whatever you write on from there is a part of that statement, and you do not want that to happen, okay? Something else to remember when programming is capitalization. Programming is very, very much so case sensitive. Uppercase dog and a lowercase dog are not the same thing. Let's go back to student ID. If I was to say student ID with the lowercase, let's do a camel case student ID variable. And let's say I set that equal to this value. If I move down in the program and I try to reference student ID, but I type it without the camel case, or I type it in any other way with the underscore or anything else, the program is not going to know what variable I'm referencing, because it's going to be like,
girl, you told us that student ID was spelled with a lowercase s in the beginning and a capital I in the ID. So don't be trying to come back up here and switching up stuff. We don't know what you're talking about.
It ain't gonna know nothing you're talking about. So it's very important that you remember that programming is very much case sensitive, and some things in the programming language, capitalized or lowercase, mean certain things without you even having to tell the program that it means certain things, which we call reserved words. So similar to reserved words are operators. Operators are symbols that we use to perform certain tasks. So for instance, we have our math operators, which are our plus, our minus, our slash for division, and our asterisk for multiplication. We also have our comparison operators, which basically compare two values. So we have our less than, our greater than, our equal to, our less than and equal to, our greater than and equal to. We also have the exclamation point for not. So for example, let's say we're comparing two values. We'll have an x value and a y value. We're going to set our x equal to 3. We're going to set our y value equal to 0. So in programming, we have these things that we call conditional statements. Basically, what I kind of mentioned before, if I said if x is greater than y, perform these tasks, which it can be print out this name, take in this input, loop this, it can be anything. So for the sake of this example, we're just gonna say, let's say for example, we wanted to print the greater value. So let's say if x is greater than y, print x is greater, right? By using that greater than symbol, we're literally, just like you do in class, you're comparing the x value to the y value. The x is greater than, so that comes off as true. If we use the less than symbol, then that will come back as false. If we use the greater than or equal to, it will come back as true, because x is greater than even though it's not equal to. If we use less than or equal to, it will come back as false, because it's not less than nor is it equal to. If we use the exclamation point, that would basically say if x exclamation point equals y, meaning if x is not equal to y, then blah 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 blah, which in this case, if x is not equal to y, would come back true, and it will print whatever we wanted it to print if the statement was true, because it ain't true. That exclamation point is a not. So the equal sign is a is, the exclamation point is a not. So whenever we put an exclamation point, that means that we're saying not whatever is next. So if we say y exclamation point equals 1, that means y is not equal to 1. Another important operator that I forgot to mention is another math operator, which is the modulo operator. That is used by the percent sign, and that basically gives you the remainder of a division problem. So for instance, the 25 divided by 7 would give us 3, but a remainder of 4. If we were to put 25 modulo 7, then it would give us back 4, which is the remainder. Hope that makes sense. So we've gone over our math operators, and we've also gone over our comparison operators. Now what's left to go over is our true-false operators. So when we talk about Boolean operators, we're referring to true-false operators. So I'm going to try to break this down as simple as possible. Now let's do it, girl. All right, let's do that. So let's say we have two variables, A and B. Now, first, we're gonna go over the different symbols, but just keep in mind, we're gonna compare these two variables. So for the OR operator, we basically are saying that if A or B is true, one or the other is true, then it will return back true. Then we have our AND operator, which only returns back true if A and B are true. If A and B are both not equal to true, meaning if we have one true and one false, then it's going to return back false. For the exclusive OR operator, we're saying that A and B have to be equal to true and false. It has to be OR. That's why it's an exclusive OR, because it's not saying we want one or the other. We're saying we want both. It's required that there are two different options in order for it to return back true. So in that case, we would need a true and a false to receive a true back. And of course, the exclamation point, which we've already discussed, means not. So if we have a value that is true and then we place that exclamation point in front of it, that means that it'll return back as false because it's saying not true. Versus if we had an operator that was false and we put the exclamation point in front of that, we're basically saying that it is true because we're saying it's not false. So another thing that is really important are the double equal signs. Very, very different from the single equal signs. So for the single equal signs, that's basically what we use in order to assign values. So for example, if we say x is equal to 3, we only need a single equal sign because we're basically just assigning a value to x. Versus down here, if we use the double equal signs, we're basically asking, is x equal to 3? Like, is that true? And if it is true, then tell us that it's true. So in this case, if we have a true variable A and a false variable B, and we put A equal B, it will return back false because those two values are not equal. Versus if we had a true value A and a true value B, and then we put A equal B, then it will return back true because both of those values are true. So they're very different from the single equal signs. So now we're just going to go through the basic true false table. I learned this in class. You can literally look it up on the internet, but we're going to go through it so we make sure that you understand exactly how all of the signs work. So in first case scenario, A is going to be equal to false and B is going to be equal to false as well. So first we have A or B, which is going to be false.
Why is it going to be false, Naya?
Because A nor B is true. So that means it has to be false. Neither one of them are true, so it has to be false. Now we have A and B. A is false, B is false. So guess what? They both come back false. Now we have A exclusive OR B. Both are false, meaning what is going to come back false because they have to be different in order for the exclusive OR to come back true. Now we have exclamation point A, which means not A, which means not false because the A is false. So if it's not false, then that means it has to be true. If A was just A alone, it will be equal to false. So if we put the exclamation point in front of it saying not A, that means not false, which means true. Hang on there with me, okay? We got 3 more scenarios to go. So A is equal to true, B is equal to false. A or B, meaning is A or B true? Which we would come back and say, yes, A is true, B is not, but A is true. So A or B would be true. Then we have A and B. Are A and B true? No, only A is true. So that means it will be false. A and B are not true. Then we have A exclusive OR B. Remember we said with exclusive OR, A and B have to be separate. They have to be A for true and B for false, or vice versa. But it has to be both true and false. So in this case, it would be true. Then we have not A. Well, in this case, A was true. So if A alone is true, then we add the exclamation point in front of it saying not A. That means it would be not true, which means it will come back as false. So now let's say that A is false and B is true. A or B would be, once again, true, because A might be false, but B is true. So that means one or the other is true. Now we have A and B. Both A and B are not true. Only B is. So in this case, it would be false. Now we have A exclusive OR B. A is false, B is true, which is exactly what we need to get a true from exclusive OR. Then we have not A. A is false in this case, so not A would be equal to true. Last case scenario, we're going to do true and true. Both A and B are true. So for A or B, it would come back, of course, true. Because not only is A true, but B is true, even though only one of them had to be true for it to come back true. Now we have both, which is the same thing for and. A and B are true, so that is also coming back as true. Now for exclusive OR, remember we have to have at least one false. So exclusive OR comes back as false, as well as for not A. A is true, so if we add the exclamation point in front of that, that means that that comes back as false. So just to ensure that we are on the right track before we wrap up this video, remember that today we discussed 3 new things. We discussed statements, syntax, and operators, all of which are very important components of writing a proper program. In order for your program to do exactly what you need to do, you must understand all of these things. So moving on next week, we'll move on to a new before the code topic, and we'll get closer and closer to starting our first code. But thank you for tuning in. Make sure you like, comment, subscribe. And matter of fact, if you made it to the end of this video, then can you comment unicorns? Can you comment that for me? Let's comment unicorns. Let's get the unicorns in the comments going, okay? It don't matter how far away you watch this video from when I posted it. If you made it to the end, baby, and you got it, you comment unicorns. Girl, you comment unicorns if you don't got it. Matter of fact, if you don't get it, if I confuse the heck out of you, then you comment a horsey. That ain't no unicorn. We ain't blind. Which, if you comment a horsey, I know I need to work on something. So, thank you guys, and yeah, subscribe.